Welcome everybody to my next installment for pre-calculus. This is our first semester exam review. And basically what I'm going to do is I am going to go over 45 questions, I believe. That's exactly what I did. Yes, I created 45 questions for the first semester exam. For my students. And I wasn't going to do this until actually a little bit later, but then I was like, well, people have exams coming up and maybe this live stream might be able to help them out. So this is going to take me a little bit going through each and every questions. Hopefully I'm going to touch on some topics that you, as you're preparing for your exam, are also going to have. The topics that we covered in our first semester in pre-calculus is going to include functions, polynomials, rational functions, and then trigonometry. So only other topic that's really, often covered would also be logarithms, which we just didn't cover. So I apologize for that, but that's not in our curriculum this year. So what I'm going to do is just kind of say hi to some people like Daly and Brandt and PB Head and Superwolf as you guys join in. I appreciate you guys joining in. Hopefully I can give you guys some value as we work through these problems. But I'll just go and take like a quick little break at the end of each page and just kind of, check in, see if you guys have any questions over the content that I've covered so far. If there are some questions that you guys have, for anything else that you're covering in your own classes, at the end, depending on how long the stream lasts, I'll be able to get into some of those. And then I don't want to, guarantee I'll be able to do it, but I am going to look into, possibly being able to go live either on Tuesday or Wednesday or both, probably from my home. So it'd be like later in the evening. And then that is just going to be without any restrictions. Basically, I will just go on live and then see whatever questions I can answer. So again, guys, I really wish I could schedule everything for you so you'd know exactly when I'm going to go live. But in reality, that is just not my life, because after I get done with school, my life goes crazy with 2 kids at home. So it's always hard to schedule things because things are always changing. So the best thing you can do, guys, is subscribe, make sure you have the notification. And then obviously, when I go live, you'll get that notification. And if that time works for you, you can hop on or you can always watch the replay. So got some more people join in. Street Hockey Boys, David, Itia, how are you guys doing? I'm so glad you guys could join. And then didn't even know calculus, accidentally came across this. Well, I'm going to be covering pre-calculus, but a lot of this stuff is a great for your calculus course as well, because obviously in calculus, one of the major issues is dealing with a lot of the algebra and trig that is taught in pre-calculus. So let's go ahead and get started. Now, I did kind of work through these, and this is going to be a little bit different as far as, what I've covered in my homework, as well as when I do like the quiz answers, because obviously this is a review. So I will try to do a little bit of explaining, but I don't have a lot of work, a lot of space to be able to show in a lot of work. So I'm basically going to kind of use a lot of like shortcuts, and kind of say some things that we're looking for. And then also maybe talk about some similar problems that you'd want to look out for. So let's go ahead and get started. And again, I'll just take a couple breaks here, for my own sanity as well as for yours. All right, so the first question says, state where the graph f of y, I don't know why that says f of y, that's kind of weird. This is an f of x. Fx equals x cubed, I'm not going to read this to you, you can see it. Has an infinite discontinuity, a jump discontinuity, point discontinuity, or is continuous. Well, remember we talked about these, discontinuities. One, they come from piecewise functions. A lot of, especially like the jumps, are going to come from piecewise functions, and this is obviously not a piecewise function. This is a rational function. And when we talked about rational functions, the discontinuities we looked at was holes, or a point discontinuity, as well as a vertical asymptote, which would be a infinite discontinuity. And those only occurred when we had values that made the denominator equal to 0. And you can see here, there's nothing that's going to make my denominator equal to 0, so therefore this function is continuous. And another way to think about that is, no matter what value I plug in for x, I'm always going to have a defined value, right? That only came into that undefined value is when we had like, a number that made the denominator equal to 0. So that is rather an easy question as long as you know the definitions of everything and know what to look for. Question number 2 says use a graph to find the intervals on which the graph is increasing, decreasing, or constant. So remember, guys, the increasing is basically when the slope is positive, the graph is going to be traveling up. Decreasing is when the slope is negative or the graph is going down. And then obviously the constant is when the slope is 0 or staying positive. And you can see here the slope is going up from here and then going down from there. So first one is negative infinity to 0. The graph is increasing. That is correct. And then it's decreasing from 0 to infinity. And again, there's no arrow shown, but this graph looks like it's continually going down in that direction. There's obviously no constant, and so we can check that as A. The next one, find the domain of the given function. So obviously here's what we were kind of talking about in that first question as far as our discontinuities. So, we have discontinuities in this case. A couple things. We can't take the square root of any negative numbers, and nor can we divide by 0. So basically, we have 2 restrictions here. We have x plus 2 times x minus 7 is equal to 0. Basically, that's going to tell you the values that are going to make the denominator equal to 0. And those are values that are undefined. They're not a part of your domain. So by using the zero product property here, I get x equals negative 2 and x equals 7. Now, the other restriction we have is we have the square root of x plus 4 in the numerator. And again, we can't take the square root of a negative number. For instance, like negative 10 wouldn't work because negative 10 plus 4 is negative 6. Can't take the square root of negative 6, or at least in our real number system. So what we're going to do is just take the radicand and set that greater than or equal to 0. And therefore we get x is greater than or equal to negative 4. So in teaching this, what I like to use is use the number line to kind of like understand our domain. So we can see at 7, let's just make 7 right here, the graph is undefined. So we're going to put a hole there, meaning there's no value for the function at 7. And then let's do at negative 2, the function is also undefined. However, the function is defined for all values that are greater than or equal to negative 4. So let's do negative 4 here, and that's going to be defined. So anything to the left of negative 4 is not defined. But anything to the right of it, not including negative 2 and not including 7, is going to be defined. So now we just basically need to figure out, which of these domains is going to work. Well, obviously all real numbers doesn't work. This is only from 0 to infinity. Well, negative 4 works, right? Negative 3 works, so that one doesn't it. And this one goes all the way to negative infinity. And we just talked about negative 10 doesn't work. So the answer here is negative 4. You can see the negative 4 is included. And then negative 4 to negative 2, which is right there, negative 2 to 7, and then 7 to infinity. And again, since these are at holes, they're not included, so our answer is C. Question number 4 is, again, another domain question. Now, the interesting thing here is we can see that these x's would divide out. Since these are separated by multiplication, we can divide out the x's. But again, just because it gets divided out doesn't mean it's not a discontinuity anymore. That just means it's a hole instead of a vertical asymptote. So to find the other values that make the denominator equal to 0, I'm just going to say, actually, just set everything equal to 0. Everything in the denominator, set it equal to 0. Even though we know that x divided out, that just means it's a hole. So now, by using the zero product property, I'm going to have to factor that out a little bit further. So that's a difference of 2 squares. So therefore, I can see that x cannot equal, or at least in the, well, let's just do x equals. So x equals plus or minus 4 and 0, because when you set each of these equal to 0, x equals 0, x minus 4 equals 0, x plus 4 equals 0, you're going to get these values. Now, these are the values that are undefined for the function. These gets divided out, so that's a hole, and then these do not get divided out, so they're vertical asymptotes. But they're all discontinuities. They're all not part in the domain. So we got to be able to find a domain here where we can say x such that x cannot equal plus or minus 4, yep, and x cannot equal 0. Well, that is our domain that we want right there. And then the last one here on this page is you can get the graph y equals negative g to the 2x by transforming the graph y of g of x in the following way. All right, so we see that we're multiplying by a negative. Now, we don't know what the function is, right? So we got to really rely on our transformations. And remember that y equals a times g of b times x minus c plus d. That is our general equation in terms of g of x of our transformations. So remember, C and D are adding and subtracting. Those are our vertical shifts and up and down, right? But the other thing to remember was everything outside the function is vertically affecting the graph. So D is shifting the graph up or down, and A is going to be reflecting it up or down. Well, if you're reflecting something up or down, you're reflecting it across the x-axis. So therefore, I know that B is not right and D is not right. So when you have a negative on the outside, that is a reflection about the y-axis. And the easiest thing I remember is, oh, that opens up, that opens down. That's a reflection of the x-axis, okay? So the next one is the 2. So now we got to think, well, what is the 2 doing? Well, if the 2 is on the outside, that would be a vertical stretch of 2. When the 2 is on the inside, we got to remember that's a horizontal compression. That's at least the vocabulary that I use in my class. You can see they're using shrink, compression, same thing, but it's definitely going to be horizontal, not vertical, because if it outside is vertical, inside is going to be horizontal. So therefore, the only one that works for the x-axis, and that is going to be A. All right, so I'll just take a quick little break, checking with you guys, and then we'll get on to question number 6. So what's up, Nick? Donji said, Donji, are you stopped doing teacher? I don't know. Hey, bro, I thought you were teaching students today. I am teaching students today. I already taught. So I don't know. I mean, it's 3:42 in Eastern Standard Time right now, so we are, I'm just doing some review after school. I wasn't planning on doing it, but, that's the way it worked. Science says, thank you for making me not fail. Well, I hope you do not fail. I hope you can continue working on this and help you out. And Mandeep, hi, bro. Hey, man, how are you doing? And, well, D-Dub, thank you very much. I'm so happy that my videos could be able to help you out. And, hey, what's up, Shiva? And David, all right. So, and Brunson, hey, how are you guys doing? Street Hockey Boys, Merry Christmas. Coming up, I'm actually going to be heading back to Michigan to go and see some family over the break, so definitely looking forward to doing that. Hopefully have a little, white Christmas and enjoy some snow for the trip. And then I got to get back, and then I got to start working on my content for next semester, because everything I've created up to this point was basically created over the summer, and I've obviously all these live streams and everything else has taken up all my time, so I'm going to have quite a bit of work to do over a winter break, but that's what I signed up for, so that's what we'll do. All right, so the next one is given an equation, you're vertically shrinking. So again, now I'm automatically thinking vertical shrinking, that's outside, okay, so I'm going to be vertically shrinking something on the outside, and then shifting the graph up 20 units. All right, well, if I'm shift now again, everything that was described here is outside the function. Everything is vertical. So the vertical shrinking is outside, right? And the shifting up or down is outside. So this is inside, so it's not that. This one has a vertical shift, or it's a shift inside, so that's not that. So it's these two. Now I got to determine which one of these is a vertical stretch, which one of these is a vertical shrink or compression. Well, remember, when A is larger than 1, it's a stretch. When A is less than 1, it's a compression. Well, 5/3 is larger than 1, 3/4 is less than 1. So therefore, since we're looking for a shrink, that is going to be answer C. And I did also work out these answers just to make sure that I didn't do anything wrong or crazy as I get through my live stream. So I'm just going to kind of keep that with me just in case I have one of those like mental blocks where I'm like, what? I already did this question. So I'll go and check it out. The next one is, which of the following statements is correct based on the formula for f? So it looks like we're trying to evaluate for f of -1. And now, again, remember that for each of these functions, this is a piecewise functions. For each of these functions, your function has a restriction on its domain, right? If I was just going to graph, 2x minus 1 where x is less than 1, then, basically all I'm going to do is, like, for instance, here's 2x minus 1. Let's just do this. Or 2x minus 1. So 2x minus up to 1, so down 2 over 1. So anyways, that graph looks like this. That's 2x minus 1. Right? That's y equals 2x minus 1. If I'm going to add this restriction where x has to be less than -1, well, guess what? Now, that graph is only this. You're not going to include all the values in that domain. So that red graph would go away, and you're just graphing this. Now again, this is x is less than, so actually I even messed that up even more because it's not included at -1. It's actually open. Down to, oh crap, gotta go. Because I know people will mark me, make sure I remember that I did that wrong. But anyways, that's what this graph looks like based on the restriction. So the red graph is based on the graph without the restriction, and then we applied the restriction, right? So I'm not going to go through all, yeah, this graph is too much to go through for 1, 2, 3, 4. But if I was going to graph this next one, again, that's an open circle right there. So let's get this red outside of there. And of course, everything's going to get mixed up. Jeez. But what you can see here is, like, these graphs are restricted, so you've got to follow the restrictions. So in f of -1, you see that there's two undefined values here because it's not less than or equal to, right? So -1, even though it's included, it's not less than or equal to, it's less than, so it's an open circle. So at -1, there's actually, we can't go to any function. It's undefined for this function, and -1 is undefined for that function. So f of -1 is undefined. It makes no sense to plug in -1 into this function because you can see it's a hole. It's undefined at that value. Now for the next one, we have f of -2. Now -2 here is not one of those, is not one of the domain restrictions in between there. So basically now I just need to figure out, well, which domain is going to be defined for -2? Well, this function has a domain that's for all values greater than 3. This function's domain is for all values between 1 and 3. And then this function has a domain of x that is less than 1. And again, like what we're asking ourselves is, what is the value of the function at -2? Well, this is the only function where we can plug in that input for -2. So I'm just going to do negative. I'm going to use parentheses because I don't want to make that mistake. Minus a -2 is 2 plus 4, which is 6. And let's go back to my red so it stands out a little bit more. So that's going to be 6. Circle that one. All right. The next one, given f of x equals x squared plus 4 and g of x equals x plus 8 divided by x, find the exact value of g of f of 2. So remember this notation. This is a composition. This is plugging one function into the other. So another way to write that is g of f of 2. Okay, you're plugging the f function into the g of function, but the f function is defined for a value. So what I'm going to do is I'm just going to evaluate what is f of 2. Well, that's going to be 2 squared plus 4. 2 squared is 4, plus 4 is 8. So now when I go ahead and plug that function in, instead of f of 2, I'm going to plug that in for 8. So I'm going to replace 8 with these x. 8 plus 8 divided by 8. Now, obviously, you can see that now just following my order of operations here, I'm going to want to simplify my numerator to give me 16 over 8, which is going to give me the answer of 2. So again, remember that g of f of x, what that's basically asking us for is that's equal to, like, f of 2 plus 8 divided by f of 2. You're plugging in one function into the other. And sometimes we don't have it for a value, or sometimes we're not evaluating, sometimes we're just composing. But in this case, it's evaluating, so I just kind of went that step earlier to get 2. The next one, now this one's a composition, and given the functions f of w equals square root of 5 minus 2w and g of w equals w squared minus 4, find f of g of f compose g of w. So again, that is really the same thing as this. All right. So again, all we're simply going to do now is just plug this g of w function into my f of w function. So again, f of stop. Hate when that does that. All right. Oh, that's the end of the page. All right, cool. So that will be f of g of w. That's going to look like square root of f minus 2 times my g of w. Right? So now I know my g of w here is w squared minus 4. So it's going to be 5 minus 2 times w squared minus 4. And then we're just going to simplify under our radical. And let's see. When I do that, I get 5 minus 2w squared. Negative times a negative is going to be a positive 8. So let's see which one would work. That's a negative 2w, and then 5 plus 8 is 13. So that's going to be our answer E. All right, quick little break, and then we'll work on the second page. So, not your average gamer says thank God final 8. That's why I decided to do this tonight instead of tomorrow. So I'm so glad. Hopefully I'm able to cover some videos or at least do some explanations that will make sense for you. So appreciate you letting me know about that, because I was like, yeah, I'll do it on Wednesday. But then I'm like, man, a lot of people don't even have exams after Wednesday, or next week. So this is a perfect time to do it. Bretson says this functions. Right now we're talking a lot about functions, but we're going to get into polynomials, rational functions, as well as trigonometry. So this is a pre-calculus review that I'm doing. Nita says, happy to be able to help you from videos. Well, I'm very happy to help you out. Dennis from Kenya, happy you could join. Kyle, helping your final grade. Awesome, man. Keep it going. And all right, so I'll just work on the exponents. I thought you were on YouTube Rewind. Yeah, I know. Somebody mentioned that on the comment. I was like, all right, so now I got to watch this YouTube Rewind video. And I don't know who that person was, but yeah, it was definitely some dude with a shaved head teaching some math. But yeah, I didn't make the cut, unfortunately, for YouTube Rewind, but I don't know who that person was. I'm not sure if it was I'm pretty familiar with many people that make math tutorials on YouTube. I watch other people's videos as well. But I didn't recognize that person. So I'm not sure if they just got an actor or if I'm just not familiar with who that was. But yeah, didn't make the cut this year. Maybe 2019. We'll see. All right, so next one is, what is the formula for the inverse of where w equals g of u, which is equal to the cube root of 3u minus 1 divided by 5. Now, I did this work. I'm not sure if I had enough. Where did I do? Oh, I did the work to the side. So I'm going to kind of use the work up here. Now, typically in my class, we really only worked on this in terms of like x and y's. I didn't really use any different variables. So that might confuse some people. There's nothing wrong with doing the different variables. But what I'm going to do is I'm just going to rewrite this. If you remember our steps from the inverse, you basically replace your f of x function with y. And then you swap the variables. And usually you're going to have y and x, right? In this case, it's going to be g of u and u. So what I'm going to do is I'm just going to write this in terms of y is equal to the cube root of 3x minus 1 over 5. I'm just a little bit more familiar with that notation. And then I'm going to kind of work horizontal, which is not preferred at all, but that's just the space that I have, so I'm going to do that. The first step you're going to do is swap your variables. So we have, and then once you swap your variables, then you basically use inverse operations to solve for y. So before I can do anything under this radical, I got to get rid of the radical. So I am going to cube both sides. Okay. Now automatically I see that my variable w, actually, you know what? That kind of gets confusing there. Either way, well, I can see my variable is cubed, which is my x cubed, which formally is really going to be my y. And so therefore, I can kind of already make the distinction here. It's not going to be that one. It's not going to be that one. Not going to be that one. So I'm looking between B and C. But let's go ahead and continue. So now I have x cubed is equal to 3y minus 1 over 5. To get the 5 off the denominator, I'm going to multiply by 5 on both sides. And 5w, so it looks like I'm looking at answer C, and that's what I got before. Yeah, it looks like I'm getting answer C. So now if I was kind of a little pressed for time, I would probably finish my answer right here because I see that 5x. Now again, remember I replaced my y, my original y value, I replaced that with an x, which is really the w. So you can see how that works. And again, if that's kind of confusing, don't worry about that. You can just treat these as y and u and then solve it that way. But then the next thing we need to do is add a 1. And then I get 5x cubed plus 1 equals 3y. And then last thing I'll do is divide by 3. And then my answer in terms of y's and x's is y equals 5x cubed plus 1 over 3. And then I basically am saying, well, which of these equations looks anywhere like that without actually resubstituting back in my equations? And you can see answer C works. Now, again, I just did that because that's what we're most used to. If you are okay with the variables, then leave them. There's no need to switch them out. However, like it comes down to another problem like this, like, sometimes, sometimes using multiple variables can get confusing. So I don't want you to feel like, that's going to be your issue here. So it says C is a non-zero real number. Okay, well, C doesn't represent a variable then. All right, well then, you know what? Let's make C equal to 3. Because again, I'll just replace this at the end. Instead of using T, I'm just going to have this be an X. And instead of Q T, I'm just going to put this in Y. So I'm just going to rewrite this as Y equals 3 over 4x minus 1. And again, you don't need to do this. This is just in case you get confused with the notation. Now, again, I'm trying to find the inverse. So do the same process. We are going to swap the variables. So I have x is equal to 3 over 4y minus 1. And so now we're just going to go and solve for y. Well, I can't solve for y when it's in the denominator. So the first thing we're going to have to do is multiply by 4y on the left and the right side. What that's going to do is that's going to get it off the denominator for me. So when I multiply it on both sides, again, I'm using this horizontal method, which is not preferred mathematically, but that's what we're going to do. That equals 3. And now to solve for y, I can divide by the x on both sides. Okay, and then now we're going to kind of work our way up. This is like horrible, but sorry about that. So I have 4y minus 1 equals 3 over x. And then I can add a 1. Oops, let's use a different color just so you guys can follow. Add a 1, add a 1, and then we'll do 4y is equal to 3 over x plus 1. Now again, remember that 3 is c, right? I just kind of did some things. And then to get rid of the 4, I'm going to divide by 4. But rather than dividing by 4, which is going to kind of look confusing, right? We don't really want to do that. We can also just multiply by the reciprocal, 1 over 4. This is the same process. So you multiply by 1 over 4, just make sure you use parentheses. So therefore, my answer now, by applying distributive property here, I get y, which is really q inverse of t, is 3 over 4x plus 1/4. And you guys can see that is not an answer choice. So, crap. Now, a couple things I noticed is that these fractions are combined. So I am going to get common denominators, multiply this by x over x, and then I'll write my final answer as y equals 3 plus x over 4x. Now again, remember the x I used to represent t, so I should be looking at a 4t in the denominator, and remember I used 3 to represent c. And so you can see our answer is C, which is the answer I previously got. So again, this is just a technique to use. If you don't like the notation, you can perfectly use the notation, not a problem. I just figured some people that might be helpful for. All right, leading coefficient test to determine the end behavior of the polynomial. So again, when we're looking at leading coefficient test, we're looking at our leading coefficient, and then our degree. So the main two graphs you should know is the squared graph, the quadratic, and the cubic. Because both of them, one of them has an even degree and one of them has an odd degree. So in this case, you can see my degree is even, so it's going to have the same end behavior as my quadratic. It's going to have the same end behavior of any polynomial that has an even degree. And that is rise left, rise right, or fall left, fall right. Then we look at the leading coefficient, and remember guys, if the leading coefficient is positive, the graph opens up, rises left, rises right. However, if the leading coefficient is negative, then the graph opens down, right? Falls left, falls right. So since this is positive and even, it's positive and even. It rises to the left and rises to the right, which is answer C. Next one, did I skip a, no, okay. For the polynomial, list each real zero and its multiplicity. Determine whether the graph crosses or touches the x at each x-intercept. So just remember when we have something in factored form where x equals k is your zero and m is your multiplicity. And remember, just multiplicity tells us the behavior of the zero. Basically, is it touching or crossing? And if it's even, that means the graph is going to touch. If it is odd, then the graph is going to cross. And so, therefore, if you can see, if I have these zeros, basically what I can do is just use the zero product property, because when we're trying to find the x-intercepts, we're basically looking at when the y value is equal to 0. So you just set the function equal to 0. I don't know why I'm rewriting this, because I'm not going to use this at all. But then you just set each one equal to 0. Now, you don't need to include the multiplicity, because what happens is when you solve this, when you use the zero product property, the first thing you do is you take the square rootable, you undo the power. So therefore, you're just going to be left with, x plus 1/2. So you can just take the factor and solve it. In this case, I get x equals negative 1/2. So obviously, these answers are not correct because x equals negative 1/2. I see the multiplicity of 2, so I know the graph touches, and you can see that one looks good. This 0 would be negative 9, and since it's odd, it's going to cross. So that answer looks good. All right, we are almost our way through. For those of you guys who are joining, I'm doing 45 questions here, and so every page, I just go ahead and take a break and check in with you guys, see how you guys are doing. But we are 15, so we got 30 more questions to go. Awesome. I'm going to actually change my pop-out chat for you guys. So let's see here. Neptune, oh really, doing a live stream without me knowing? I am so sorry, Neptune. Hopefully you subscribe and get a notification, so therefore next time you can check. I kind of mentioned I can't always, I've always wished I was planning on doing a live stream on Wednesday, which I still think I'm going to, but I don't think I'm going to do anything that I have planned. I think I'm just going to turn on my live stream, and then whatever questions you guys have, I will try to help out. So for that, hopefully that will help out for you guys that are taking exams, on Thursday or Friday or next week. And then I'm kind of thinking I might just want to do a live stream as well tomorrow. I don't know. We'll see how it goes. Just choosing to them if we want to have a career out of these. Exactly, Dylan. Honestly, I'm not sure what else, Dylan. Honestly, we are forced to do these instead of just choosing to do them if we want to have a career out of these. I'm not sure what you are referring to, Dylan. Dylan, because math. Are you saying why you're forced to do these? Yeah, I mean, there's a lot of cases, and obviously I have a lot of things I'd like to talk about as far as the purpose and future of math education. I'm not going to get into that for that live stream because I have way too many math problems to go into, but I guarantee you, when we have next live stream that I don't have anything prepared, I'm probably going to have to do some off the cuff just talking while I'm waiting for some questions. And so maybe I'll definitely do some remarks as far as why you're learning this stuff, why is this even a part of that? But Dylan, if you want to rephrase that, I'd be more than happy just to kind of reread and check that out. Not Your Average Gamer says, will you review logs? Unfortunately, no, I'm not going to be reviewing logs. That's not a part of my curriculum this year in for pre-calculus. I do have a ton of older videos on logarithms and exponential functions. It's just not on our review. So unfortunately, I'm not going to cover anything with that. However, if I do my live stream tomorrow or as well as Wednesday, I'll be more than happy to do any problems that you have on logarithms for you. And Kakan says, hi, how are you doing? All right, let's go ahead and work on the next page, and then I'll take another break. We are at question number 15 out of 45. So find the x-axis of symmetry of the parabola given y equals x squared minus 14x plus 3. Now, if you remember from Algebra 2, x equals opposite of b divided by 2a. That would be the quickest and the fastest way to find the line of symmetry. Or we could also go ahead and write this in vertex form. X minus k squared, or x minus x minus h squared plus k, where the axis of symmetry is x equals h. Now, this is the easiest and the fastest way, and I would just recommend doing that if you remember, if you have it in standard form, ax squared plus bx plus c, right? And I would just plug it into that formula, and hopefully you guys can see that the answer is -7. However, I am actually going to do this a little bit more work. I'm actually just going to review completing the square, just because I know that is a very touchy point for a lot of students. And if they have another problem where they have to complete the square, or they have to find the whole vertex, and they don't like plugging in that number back into the formula, then let's just cover completing the square real quickly. So remember, completing the square is basically that same b divided by 2 squared. So in this case, my b is a -14 divided by 2 squared, which is a -7 squared, which equals 49. All right. So basically what I'm going to do is I'm just going to rewrite this equation as x squared minus 14x. And now what I'm going to do is add in that 49, because what I'm doing is I'm completing a perfect square trinomial. However, you just can't randomly add a number on an equation and not make sure your equation is still equal. So therefore, I'm going to have to immediately subtract 49 and then keep that 3 is still there as well. Now, what we've done is we completed the square. We have created a perfect square trinomial. And that, ladies and gentlemen, can be factored down. And it's a perfect square trinomial. So we say, what two numbers that are exactly the same multiply to give you 49? Well, again, it came from here, right? It's 7, or -7, I'm sorry. So -7 times -7 is 49. -7 plus -7 is 14. And again, that comes from the dividing by 2. So you can just work your way from here to find your answer. So therefore, this in vertex form is y equals x minus 7 squared. And then, now you don't really need to worry about that, but that'd be -46. No. -46. Now again, we're just looking for the axis of symmetry, which is x equals 7. So I did make my mistake here because that's a negative. That would have been a negative, right? Yeah. So anyways, my answer is C, which is -7, which let me just double check, make sure I did that correctly before, which I did. Yeah. So the answer is actually C. So you can see, like, when you're taking these exams, you know, if you're trying to do everything all the time in your head, you can kind of quickly make some mistakes. All right, next one, binomial expansion, the fifth term in the expansion of 4x plus 3. And I have my calculator. It's low on batteries. Hopefully, actually, do I have my other calculator? I do. I got the teacher one. Let's see, this one's like dead on batteries too. No, this one's charged. All right, good job. Okay. So in this one, we're looking for the fifth term of the expansion. And you know what? I don't like that. Let's get you out of there. There you go. All right. So I think the easiest thing to work on with this is, you know, understanding our expansion here. If we're going to expand this, you know, what I showed with my students is the first term is always going to be to the highest, you know, to that first power. And then the second term is to the 0. And then we just keep on following our expansion, just going in descending or descending powers with the first term and ascending powers with the second term. So then this is 4x to the fourth, 3 to the first, plus 4x cubed, 3 to the second. I don't know why I'm using parentheses for that one. Plus 4x squared, 3 cubed. I'll zoom in again for you guys. And then the last one is 4x to the first, 3 to the fourth. Now I'm going to stop here because it's asking us for the fifth term. So this is the first, second, third, fourth, fifth. Now again, this isn't it though. This isn't all of my terms. I do want to figure this out, like what exactly this term is. But remember, we have our coefficients, and our coefficients come from Pascal's triangle. So when we have just to the 0 power is 1, To the first power would be 1, 1. And then when we have something raised to the second power, the coefficients are 1, 2, 1. To the third power is 1, 3, 3, 1. And again, I'm just getting these values by adding these terms to get to the next one. So by following the pattern of Pascal's triangle, a fourth expansion would be 1, 4, 6, 4, 1. And then the fifth term expansion would be 1, 5, 10, 10, 5, 1. And again, my fifth term is 1, 2, 3, 4, 5. So let's circle that. So then that is going to be my coefficient. Okay? So basically, the question that I'm asking is, what is 5 times 4x to the first power times 3 to the fourth? Well, I don't know 3 to the fourth off the top of my head, so I'm going to use my calculator. So 3 raised to the fourth power is 81. Actually, I should have known that. That was kind of embarrassing. Anyway, but I don't know 81 times 5 times 4, which I could probably figure it out, but then I'd, be taking a while. So let's do 5 times 4x times 81. And actually, guys, this isn't that bad. 5 times 4 is going to be 20, all right? Oops. 5 times 4 is going to be 20. 20 times 80, it would be 1600, and then there's an extra 20 there, so it'd be 1620x, right? I didn't need to use my calculator. Should have. Hands off. All right, let's go to the next one here, which is going to be, I got to get my hotkeys back. Find the zeros of the polynomial f of x equals x cubed plus x cubed plus x cubed plus x squared minus 6x. All right, so we got to find the zeros. So again, guys, remember, finding the zeros, we're basically setting our function equal to 0. 0 equals x cubed plus x squared minus 6x. All right, so I notice here that they all have an x in common, so I'm going to factor that out. 0 equals x times x squared plus x minus 6. And then I can factor this again one more time. 0 equals x times, factoring my trinomial, what two numbers multiplied to give me negative 3, add to give me a positive 2. That's going to be an x plus 3 and an x minus 2. Okay, now I have the product equal to 0, so I can set these all equal to 0. So I can say x equals 0, x plus 3 equals 0, and x minus 2 equals 0. And therefore you can see my solutions are, my zeros are x equals 3, x is equal to a negative 3, and x is equal to 2. So the only answer that works in that, and the only answer that works here, 3, negative 3, 2, negative 3, 2, and 0. So that's answer C. I lost my stream, so sorry about that, guys. Not sure what went on, but I am hardwired in there, so I'm just going to continue on going in from there. So I just finished up question number 17. And then obviously we'll go ahead and get into question number 18. So again, we're looking into zeros. We're looking into solving this equation, but doesn't look like this is going to be anything fun to factor, or does it even look factorable by grouping. So the next thing then is I'm given a 0, so that means x equals 4 is my 0, and that means x minus 4 is my factor. So if we're going to use long division, we'd want to use the factor, but we're using synthetic division, we can just use that 0. And if you remember, for synthetic division, you take the 0 on the outside, and then you take the coefficients of your polynomial and write them up top. So we'll have 3, negative 32, 73, and then 28. So in this case, remember, for synthetic division, you bring down the first term, which is a 3. 3 times 4, which is 12. Negative 30 plus 12 is a negative 20. Negative 20 times 2 is a negative 80. 73 plus negative 80 is a negative 7. Negative 7 times negative 7 times 4 is going to be a negative 28. Man. Sorry guys for my bad stream. I'm not sure Not sure why I'm getting a bad stream signal for you guys, but hopefully everything will be able to pick up all right for me, or at least hopefully it's not too bad. If you guys can just kind of let me know if it's choppy or if the audio is going back, because right now I'm getting not a very strong signal, so I'm not sure if that's at the classroom level or whatever else, but either way, I'm just going to kind of continue working my way through this. And actually, no, if you guys can just that's very, very important for us to be able to have in this. It's better now for me. All right, cool. Thank you. So we have a 0, so that means that worked. Our division worked here. And now what we're going to do is, this is a factor, right? X minus 4 or x equals 4 is a 0. That means x minus 4 is a factor. And then this is your other factor. So remember, just like we did here, you have your factors. You can set them equal to 0 to find the zeros. So I'm going to set this 3x squared minus 20x minus 7 equal to 0. And now what I'm going to do is go ahead and solve. Now this, first thing I want to do is check if it's factorable, and I can kind of see that, yeah, this actually I think works. So if I have 3x and x, all right, I need to get to -7, so I'm thinking, well, what two numbers multiply to give -7? That's -7 and 1, or -1 and 7. And then I need to get to -20. Well, I immediately know that 3 times 7 is 21, and then 1 times, 1 times 1 will obviously give me 1, so that's going to make that work here. Streamed. Jeez, oh man. Let me try something. Let me see if this helps. Let me try something. Sorry, I'm just working on my... Sometimes at school, I don't get the best internet. So unfortunately, like when I'm not getting the best internet at school, that obviously is going to be impacting my stream quality for you guys. But hopefully if you guys can maybe just give me a thumbs up. I just kind of worked on some things, checked on my stream. It shows me right now that the stream is not coming through, but... hopefully you guys give me some comments here, just kind of let me know, or some thumbs up, let me know that if it's working a little bit better. I'd hate to have to cancel the stream, but I'm just going to keep on working on it. I can see it's not coming over full for you guys, but hopefully I'll just keep on monitoring it, and hopefully it's not going to be too bad for you. It's not coming over too bad. All right, so going back into this, 3x squared minus 20x minus 7. All right, so there you go. I guess we'll just kind of see. It's sometimes at school, I don't know, they're always testing things or turning down the network. So apologize for all of that, guys. But hopefully my little correction helped out. So again, to factor in this, I know that multiplying 3 times -7 is -21, and then obviously you are going to. 1 times 1 is 1, so that's going to give you that difference. So if I need to get to a -21, I'm going to make this a -7, and then make this a +1. And now I have these two factors, so by setting them, doing the zero product property, I'd get x equals -1/3 and x equals 7. And so obviously we already know 4 is a 0, so it has to include 4. We have -1/3, which is this one, not that one, and then 7. So it looks like the only answer here is B. Yep, there we go. All right, next one, solve the equation. Well, hey, here's a quadratic. This is going back to Algebra 2 days, right? And again, this one is obviously not going to be factorable, as you can see from our answer choices, so therefore we're going to have to use our lovely quadratic formula. Opposite of B, plus or minus the square root of B squared minus 4 times A times C all over 2 times A. All right, so again, remember in standard form, ax squared plus bx plus c. So let's go and plug it in and see what we get here. Opposite of b is 7 plus or minus the square root of -7 squared minus 4 times -3. Now, obviously, we know it's all 23 here, so that's kind of nice. I don't really need to do the math. 4 times A times C, -6. the main important thing is we need to determine, is it going to be a negative 23 or a positive 23? Because if it's negative 23, that's where the I comes from. If it's a positive 23, there's no, we're not going to have an I. So, and then we have 2 times negative 3. Okay, so there's a couple things that we can actually work on to like skip, assuming actually we don't go and use our calculator. So if I go ahead and do this a little bit more here, I'm going to have 49. Now, negative 4 times 3 is going to be a positive 12, and then 12 times 6 is going to be a negative 72. All over a negative 3. Now, obviously, guys, we know that the difference between 49 and 72 is 23. The answer is all there. But is it positive or it's negative? You can see it's negative. So anything that doesn't have an I is not going to be an answer choice. Now, oops, that's negative 6, right? 2 times negative 3, which is negative 6. So now when I distribute a negative 6, though, 7 divided by negative 6 is going to make that negative, whereas here it has this positive. So I can see, obviously, I'm going to have my I, but since this is a negative 6, remember you're dividing each term by a negative 6, so therefore I can see that answer A is going to be my answer. All right, write the linear factorization of the polynomial, so more factoring. In this case, we have x to the 4th minus 6x squared plus 8. Looks like I have good live stream coming in. Cool. So x to the 4th minus 6x squared plus 8. So we just got to factor this. And again, a lot of times, guys, you can see this as a trinomial. Sometimes it might be helpful just to think of this as x squared minus, 6x plus 8. How would I factor that? What two numbers multiply to give me 8? Add to give me negative 6. Well, that's x minus 4 times x minus 2. So in this case, you can see, well, it's the same thing. Just raise the power of the factors. X squared minus 4 times x squared minus 2 equals 0. Now here, it's going to be helpful to kind of like use our zero product property, because you can set each of these factors equal to 0 to solve. Now you could use the square root method, add 4, or factor by difference of 2 squares, but hopefully you guys see the answer is x equals plus or minus 2. For this one, we have x minus 2. Oh, I'm not trying to solve. Let's just continue well, I guess I was doing that. Yeah, that's fine. I'll continue using it that way. So I'm using the zeros, so therefore we can write this as the linear factorization. Because remember, once you have a 0, you can easily rewrite it as a factor. So when I go ahead and solve this, add 2 and then take the square root, I'm going to get x equals plus or minus the square root of 2. So therefore, the linear factorization, if you can't do this without solving, is x minus 2, x plus 2, right? That's factor that factor down. And then if these are my zeros, I can write these as factors as x minus the square root of 2 times x plus the square root of 2. Okay, and so the only answer that one works is D. All right, number 21 says f of x equals 4 times x to the 3rd minus 3x squared minus 10x plus 4 between negative 2 and 1. And what the question is actually asking is, there a 0? Okay. So basically, what we need to be able to determine, guys, is using the intermediate value theorem. If we have a continuous function and we have a value of the function that is negative and then another value of the function that is positive, between those two values there must exist a value where the function is equal to 0. And to explain this is the easiest way to look at this is just by looking at a graph. But we can see here we have like f of negative 2 and then they have f of negative 1. So let's just go and evaluate for those functions and then see if we get the same values, and then we can determine if it's positive or if it's yes or no. So f of negative 2, and I kind of forgot to write the question in there. So to evaluate f of negative 2, we're going to do 4 times negative 2 cubed minus 3 times negative 2 minus 10 times negative 2 plus 4. Okay, so we have negative 2 raised to the 3rd power, which would be a negative 8. So I have 4 times negative 8, and then minus 3 times negative 2. This would be a positive 20. Let's just rewrite that. Negative 3 times negative 2 is a positive 6. That's a positive 20, and then it's a positive 4. Okay, the reason why I want to do that is that becomes 26, that's 30, and then, oh, wait a minute, what did I do? That's negative 8, so that's a negative 32. That's that's squared. No wonder. I was wondering why. I'm like, I didn't get that as an answer. So anyways, that becomes negative 2 squared is 4. 4 times a negative 3 is a negative 12. All right. So now we have a negative 32 minus 12, which is a negative 44, and then plus 24. So you can see here that will end up giving you a negative 20. So obviously, these two answers don't work. Now, obviously, we can go and see what is f of negative 1, and actually that will answer our question for us if it's either positive or negative. So let's figure that out. So f of negative 1 is equal to 4 times negative 1 cubed minus 3 times negative 1 squared minus 10 times negative 1 plus 4. So that becomes a negative 1 cubed is negative 1 times 4, which is a negative 4. That's a positive 1, so that's a negative 3. This becomes a positive 10. And then that's a plus 4. And so you can see it's a positive 7, which the answer is yes. Now again, let's just kind of look at this. If what the basically intermediate value theorem is saying is if at negative 2 we have negative 20, so negative 2 we're at like negative 20, and then at f of negative 1 we're at 7, positive 7, you can see if this is a continuous function, right? And then there's one value and there's another. As long as it's a continuous function, there has to exist a value between negative 2 and 1 where this graph crosses the x-axis, right? And that has to be the case as long as it's a continuous function. But either way, we can actually get around that by just evaluating both of our functions there. All right. So now we'll just go and take another break here. Check in with you guys. Again, this is on my number question 22 of my 45 question exam. Thank you guys for joining in. I apologize for my connectivity, issues for you. But Angie, you're coming back through on my phone, but frozen on my laptop. Yeah, sorry about that. Also want to say hi. Thank you for the videos. You are very welcome, Austin. And Connor, geez, my next YouTube rewind quality, huh? Yeah, exactly. I guess maybe that's why I didn't make it. Make it on the YouTube rewind for my quality, but it's not actually my quality. It's my internet at school. So, yeah, I don't really have much control over the internet. I think the internet went like two more times when I was at school today. Just kind of crazy stuff. So, again, guys, I have 23 more questions that I'm going to work on, so I'm almost halfway over. But if you guys have some questions you'd like me to address, then I'll be more than happy to. Otherwise, I am just going to continue working on this stream. I mean, it seems like it's going pretty well so far, and then I'll just keep on knocking through it. But if you do have some questions and you stay on long enough, then I'll try to answer them as best I can. Will you go over Calc Semester 1 tests such as integrals and derivatives? Isaac asks. And hey, Isaac, unfortunately, no, I'm not going to be able to cover calculus. I've taught it for the last 2 years. I'm not teaching it this year. And it's just a little too much stuff. Like pre-calculus is just, doing everything I'm doing online for pre-calculus. It's just kind of a little bit overwhelming for me too. And then hopefully, I'm hoping for next year I get back into the calculus. And then what I'd like to do is do this exact same thing for calculus. So therefore, any student that is moving their way up from pre-calculus to calculus, I can help them out with. That is just the goal. All right, so let's go ahead and move on so this stream hopefully doesn't take that long. So it says find the nth degree polynomial function with real coefficients satisfying the given conditions. N equals 3, that is the degree. And then and then we have negative 2 and negative 3 plus 2i are our zeros with a leading coefficient of 1. So again, guys, just remember that we can rewrite these like this. X equals negative 3 plus, X equals negative 3 plus 2i. And again, remember if X equals negative 3 plus 2i exists, then X equals negative 3 minus 2i. must also exist, right? So what we're going to do is want to write these as factors and then basically multiply them by each other to get our polynomial. So I'll just say y equals, in factored form, if these are our zeros, then my factors would be x plus 2, and then x minus 3. Oh, let's do x plus 3, sorry. X plus 3 minus 2y, and then x plus 3 plus 2i. Okay, so again, all I did was I took each of these zeros, set them equal to 0 to write them as a factor. Now I need to multiply these, and I'm going to use my shortcut because it is an exam. So you could just use, your methods for multiplying these, multiplying a trinomial times trinomial. I like to group the first two terms here, and then notice that this is a difference of two squares. So therefore, when I'm multiplying this, I'm not going to do anything with the x plus 2 right now. But when I multiply this, I'm actually getting x plus 3 squared, and then this is going to be a minus 4i squared. And that's a little bit easier for me to kind of work my way through. I don't like those 2's here. Just because what that does is that creates a binomial, a binomial squared, which I can easily multiply my way out. So when I expand x plus 3 squared, I know that's going to be, let's use that as a bracket actually. That's going to be x squared plus 6x plus 9, and then negative 4i squared. Remember, I squared is negative 1. Negative 1 times a negative 4 is going to be a positive 4. Okay, so now to get my answer, I need x plus 2, and then times x squared plus 6x plus 13. All right, and then in this case, now I'm just going to use distributive property. I'm not going to do any box method or anything crazy here. I'm just going to multiply these out and see what I get. So when doing that, I get x cubed plus 6x squared. X times 13 is a positive 13x. And then 2 times x squared, which is 2x squared. 2 times 6x, which is a positive 12x. And then 2 times 13 is a positive 26. Okay, so obviously that one doesn't work. 13x plus 12x is a 25x. That one works, that one works. That one doesn't work. And then 6x squared plus 2x squared is an 8x squared. Oh, okay. But that one didn't work for that one, and that one doesn't work. So therefore, it looks like our only answer here is D. Let me go and check. Oh, did I take a break? Oh man, I'm like, did I staple these wrong? What problem am I on? 22? Oh, there I am. Yeah, D. Okay. All right, next one is use the rational root theorem to list all the possible zeros of the polynomial. So remember, this is like your P over Q. So we have P over Q. And basically, remember, the rational zero type just gives you the list of possible rational zeros. It doesn't tell you what the rational zeros are, just the list of possible. So all we're going to do is plus or minus the factors of P over plus or minus the factors of Q. Well, the factors of 7 are just 7 and 1. And the factors of Q are 15, 5, 3, and 1. So obviously, I know this answer doesn't work because all the factors of my Q are in the numerator. So that one doesn't work. Obviously, it is, I put them in parentheses, so you should put them in parentheses. Obviously, these are not written as fractional form. You see that you'd have fractions like 7 over 15. Well, 7 over 15 is one of my rational fractions. Right? You basically, I don't want to do all of them, but you do 7 over 15, 7 over 5, 7 over 3, 7 over 1, 1 over 15, 1 over 5, 1 over 3, 1 over 1. Well, obviously that one doesn't work. And then these obviously are not rational zeros either. So my answer is D, because it's asking for all the possible rational zeros. All right, next one. Question number 24 is multiplying rational expression. So in this case, if you remember when doing operations with rational functions, we want to simplify. All right. So what we're going to want to do is factor. I'm just going to rewrite this. So this is equal to, in factored form, what two numbers multiply to give me 56, add to give me 15. Hopefully you have so much practice with factoring that you start to see these patterns here. And then this one is going to be x plus 8 times x minus 7, because we need it to give you negative 56, times difference of two squares. So this is x minus 8 times x plus 8. And then over here, it's the same as this one, but now the larger term has to be negative. So that would be a x minus 8 times an x plus 7. All right, so now what we can basically do, guys, is just go ahead and apply the division property. Since everything, all these terms and expressions are separated by multiplication, we can just divide out terms that are exactly the same. X plus 8, the x minus 8s, and the x plus 7s. So therefore, that leaves us now with x plus 8 over an x minus 7. And we find our answer here is D. All right, next one is adding and subtracting. Now remember, guys, to add and subtract, we got to have common denominators. So to determine if we have common denominators, obviously we don't have common denominators, but we don't want to like multiply both sides, by the other denominator here. We're going to want to factor and simplify. So let's just go ahead and factor these first and kind of see if they can be simplified before we have to get common denominators. So to factor this, that's going to be x plus 5 times x plus 2. This factored would be x, plus 5 times x minus 1. This factored would be x plus 2 times a x minus 1. And this factored would be an x plus 5 times an x plus 4. Okay, so basically I am just rewriting these in factored form. Now, what's nice about writing them in the factored form is I can't like cross out across them, even though there's not, like I can't divide out these x minus 2s like I did up here. And the reason why is because of this addition symbol. But I can simplify for across the same expression because within the same expression, they're separated by multiplication. So we can say the x plus 1s divide out here, and we can say the x plus 2s divide out here because, again, these are separated by multiplication. So in reality, what I really have is x plus 5 over x minus 1 plus x minus 1 over x plus 4. Now I'm going to want to get common denominators. This is a good problem. And then this one would be x plus 4. And I am hungry now. All right, so now you multiply to get common denominators. Now I already know my denominator here is x minus 1, x plus 4, right? So I guess basically got my two options. Not going to be this one. So I'm not really going to be concerned. What I'm going to do now is I'm just going to focus on what the answer would be in the numerator, not really working on the denominator because I know that's my answer for the denominator. So I'm going to need to multiply these by using distributive property. Right, expansion of binomials. Now I'm going to do this in my head. So this first one is going to be x squared. Oh, let's just put it down here. So this will be x squared plus 4x plus 5x is 9x plus 20. And then this is a binomial squared. So that would be x squared minus 2x plus 1. Okay, so those would be the numerators there. And then obviously we have the same denominators. So when I combine like terms in the numerator, I get a 2x squared. 9x plus negative 2x is going to be a positive 7x. And then 20 plus 1 is a positive 21. So therefore, I'm looking for my answer, and it looks like it's answer B. And there you go. All right, number 26. Looks like a complex fraction, but really it's just a rational function divided by another rational function. So all I'm simply going to do in this case here is just multiply by the reciprocal, right? Whenever you're dividing by a fraction, that's the same thing as multiplying by its reciprocal. So I'm just going to multiply by my reciprocal. That's a minus 7. Now, actually, I should probably divide that out, right? Because when we're doing rational functions or simplifying rational expressions, you kind of want to get like what this, like anything how it is simplified. So let's just actually rewrite this as d minus 3. If I was going to factor this out in d's instead of x's, my larger, what two numbers multiply give me negative 20, add to give me negative 1, where the larger term is negative, so that's going to be x minus 5 times x plus 4. And then that's going to be divided by d minus 7 over d plus 4. Okay, now I'll go ahead and multiply by my reciprocal. So now when I go ahead and multiply by a reciprocal, d plus 4 over d minus 7, you can see I start to get some division that's going to be happening. And my x plus 4s, actually we're going to have to use a different color. Let's go and use brown because nobody likes brown. So d plus 4s divide out. And therefore you can see that I am left with now a d minus 3 times, or d minus 3 in the numerator, and then d minus 7 and d minus 7. And why did I use x's? Those are d's. d minus 7 times d minus 5. And they got some crazy answers. It wasn't that bad. 26 is A. All right, ladies and gentlemen, we are working our way through. So we're almost done with rational functions, and then we're going to get on to trig. Whew. All right, I don't know if I can handle this, but I'm going to try to do my best. So, oh, crap. I'm probably not going to be able to. Well, I'm probably going to have to join later, guys, actually, because I'm going to have to, I got to leave. Crap, I got to leave like right now. Well, this is number, so I'm going to have to end on number 27, guys. I totally apologize. I like completely lost track of time. So what I will do for you guys is we're going to continue the stream, and I'll probably just do like a part 2. I'm either going to do it back tonight or I will do it tomorrow. But yeah, so we're going to have to end on 27, and then I'll come back to finish these up. But I'm sorry, I got to go and pick up my kids. So kind of totally forgot about that, but hopefully for this part it helped you guys out. Also, tonight I will have these uploaded, and what I'll do is I'll put my answers as well as the blank answer in the comments down below. So therefore you guys can, print that out if that helps you guys out. So hopefully that helps you guys out. Sorry about that. I totally lost track of time, but I'm going to go ahead and get all this wrapped up so I can head out, and look out for the live stream on part 2 coming out shortly. So that will work out for them. Have a great day.